Kubernetes and GKE Part 31. This episode has 3 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain containered. Here's a strong way to approach it. Containered is a lightweight, high-performance container runtime that manages the complete life cycle of containers in systems like Kubernetes. It is one of the most widely used container runtime interface, CRI, implementations today. Core idea: containered is the engine that pulls images, creates containers, and runs them efficiently on a node. It is responsible for running containers, not building them. Why containered is used? It was created to replace heavy Docker runtime components inside Kubernetes, improve performance and stability, provide a simpler, modular runtime, follow Kubernetes CRI standards where containered fits in Kubernetes. Kubernetes kubelet. Containered runt containers. Kubelet sends instructions. Containered manages lifecycle. Runt actually creates containers. Architecture of containered. 1. High-level responsibilities: image pull from registry, container lifecycle management, snapshot management, networking hooks via CNI. 2. Low-level execution delegates, container creation to runt, uses Linux namespaces plus grubs. Key components: 1. Container daemon runs in background, handles API requests from kubelet or CLI. 2. CTR or NERDL. CLI tools used to interact with containered. How containered works. Flow. 1. Kubelet requests container creation. 2. Containered pulls image from registry. 3. Containered prepares file system snapshot. 4. Containered calls runt. 5. Runt creates container using Linux kernel. 6. Container starts running. Key features: 1. Image management, pull, push, store images, supports OC, Open Container Initiative, images. 2. Container lifecycle, start, stop, pause, delete, restart. 3. Snapshot management, efficient file system layering, overlays. 4. Kubernetes integration, uses CRI plugin. Containered default runtime in most clusters today. Containered versus Docker feature: container Docker purpose runtime only, full platform build, images cross mark no check mark yes. Kubernetes usage native deprecated, shim removed. Weight lightweight, heavier performance high moderate. Containered versus runt component role: containered manager, lifecycle plus images. Runt low level container creator. Simple analogy: think of a factory. Kubernetes equals manager, containered equals factory supervisor handling workflows. Runt equals machine that physically builds the product. Container. Why it replaced Docker in Kubernetes. Docker had extra layers, UI, build tools. Kubernetes only needed runtime. Containered is simpler and faster, better compliance with OC standards, real world usage. Default runtime in GKE XAKS. In many setups. Modern Kubernetes clusters. Benefits: lightweight and fast, stable and production-ready. Kubernetes native CRI support, modular architecture, widely adopted in cloud environments. Limitations: no image building capability. Need Docker or build kit for that. CLI is less user-friendly than Docker, requires understanding of Kubernetes ecosystem tools. Interview-ready definition: containered is a lightweight, industry-standard container runtime that manages the life cycle of containers by pulling images, managing storage and snapshots, and delegating container execution to runt. And it is widely used in Kubernetes clusters as a CRI-compliant runtime for running workloads efficiently. Nice. Let's continue. Question 2. What is CRIO? Here's a strong way to approach it. CRIO is a lightweight container runtime designed specifically to run containers in Kubernetes using the Kubernetes Container Runtime Interface, CRI. Core idea: CRIO is a minimal, Kubernetes-focused container runtime that replaces Docker for running pods efficiently. It is built only for one purpose: run Kubernetes workloads. No extra features. Why CRIO exists? Earlier Kubernetes setups used Docker, but Docker had unnecessary components, build tools, CLI, etc. Kubernetes only needed a runtime, so CRIO was created to be lightweight, be Kubernetes native, follow OC, Open Container Initiative. Standards reduce overhead and complexity where CRIO fits in Kubernetes. Kubernetes kubelet CRIO runt containers. Kubelet communicates via CRI. CRIO handles container life cycle. Runt creates containers at low level. Key features of CRIO: 1. Kubernetes native design built specifically for Kubernetes CRI. No extra Docker-like features. 2. Lightweight runtime, minimal dependencies, smaller footprint than Docker or contained stacks. 3. OC compliance supports OC container images. OC runtimes like runt or cron. 4. Image management pulls images from registries, Docker Hub, ECR, etc. Uses standard container image formats. 5. Security focus, simple attack surface, no unnecessary daemon features, works well with SE Linux. Secomp architecture of CRIO components. CRIO daemon handles CRI requests, runt or cron, low-level container execution, image libraries, pull or store container images. How CRIO works: 1. Kubelet sends pod request via CRI. 2. CRIO receives request. 3. Pulls required image from registry. 4. Sets up container file system. 5. Calls runt to create container. 6. Container runs inside pod. CRIO versus containered feature. CRIO containered purpose, Kubernetes only runtime, general container runtime, scope narrow, broad complexity, very low features, minimal rich ecosystem. Adoption OpenShift heavy, widely used in cloud. CRIO versus Docker feature. CRIO Docker Kubernetes usage, native CRI runtime deprecated in Kubernetes, extra tools none. Build CLI compose weight, lightweight, heavy focus, runtime only, full platform. Simple analogy, think of Kubernetes equals factory manager, CRIO equals minimal machine that only produces containers, containered equals slightly more versatile machine system where CRIO is commonly used. Red Hat OpenShift primary runtime. Enterprise Kubernetes distributions, security focused environments, lightweight cluster setups, advantages, very lightweight, strong security posture, Kubernetes specific optimization, easy to maintain, fast startup. Performance limitations, less feature-rich than containered, smaller ecosystem, not suitable for non-Kubernetes use cases, less CLI tooling support. Interview-ready definition: CRIO is a lightweight, Kubernetes native container runtime that implements the container runtime interface, CRI, and is designed specifically to run OC-compliant containers in Kubernetes clusters by delegating container execution to low-level runtimes like runt, offering a minimal and secure alternative to general-purpose runtimes like containered or Docker. Great, moving on. Question 3. Explain pod security standards. Here's a strong way to approach it. Pod security standards, PSS, in Kubernetes are a built-in set of security policies that define how restrictive a pod security configuration should be. They replace the older pod security policy, PSP, mechanism and are used to enforce baseline security rules at the namespace level. Core idea: pod security standards define how safe or restricted pods must be before they are allowed to run in a cluster. Why pod security standards exist? They help to prevent insecure container configurations, reduce attack surface in clusters, enforce security best practices, consistently replace deprecated pod security policy, PSP. The 3 pod security levels: 1. Privileged, least restrictive, maximum flexibility. Minimal restrictions allows almost all capabilities used for system components or trusted workloads. Characteristics: can run as root, can use privileged containers, no restrictions on Linux capabilities. 2. Baseline, moderate security, balanced security for general workloads. Blocks known unsafe configurations, allows most standard applications to run. Characteristics: prevents privileged containers, disallows host access, host network, host PID, etc. Restricts unsafe Linux capabilities. 3. Restricted, most secure, strong security enforcement, zero trust style, enforces strict best practices designed for production workloads with high security requirements. Characteristics: must run as non-root, requires read-only root file system, drops all Linux capabilities by default, enforces secomp profiles. How pod security standards are applied: they are enforced using namespace labels. Example: baseline mode kubectl label namespace dev pod security Kubernetes IO or enforce equals baseline. Example: restricted mode kubectl label namespace prod pod security Kubernetes IO or enforce equals restricted. Enforcement modes: 1. Enforce blocks non-compliant pods. 2. Audit allows pods but logs violations. 3. Warn shows warnings but allows creation. Example: pod violation, restricted mode, this would be blocked. Spec: containers, name, app. The exact commands and code are in the written question bank. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.